right, hi friends. We're going to talk through worksheet 7 tutorial. So this is worksheet 7, bricks and blocks, and we are going to do number 4, which is an interesting problem because you have to write all of your answers in terms of F, aka the force that is pulling these blocks. So step 1, as always, is to draw FBDs for your 2 blocks. So F on A, which again is this big block, we've got a force of tension from these little hooks that are right here. And this is on A by B. We have no friction, so friction is negligible. That means friction isn't in the system. There's like smooth surfaces, so there's no friction. There is a force of gravity on A, and there is a normal force on A. So these two are going to be equivalent. And now I'm ready to do my block B. So block B, we're going to have a force of tension on B by A, because if B is pulling on A, which it is, that must mean that A is pulling just as much on B. So these two forces are equivalent. That force of tension is going to be the same for those two blocks. They're applied on each other, and we know because of Newton's third law, F on A by B is equal to the opposite of F on B by A. That is Newton's third law. So then we also have a pull force of F from the hand that is just applied on B, because that pull is only in contact with B. That string that the man is pulling is only in contact with B. It's not in contact with A. So this one also has a force of gravity and a normal force. Okay, so I need to determine the net force of my system, and I need to actually draw an FBD for this system. So when I draw an FBD for this system, I am going to eliminate forces that don't really mean anything. So FT on A by B and FT on B by A, those two forces are going to cancel each other out. So I could draw them. But because they're equal and opposite, they're just going to cancel each other out. So really all I'm left with in the horizontal direction is this force F. And in the vertical direction, again, kind of similarly, I have my FG, my FN, and those two are going to cancel each other out. But I'm going to instead do an FG on my system and an FN on my system. So like the both blocks together. And then I can determine what the net force is on my system. And this is actually just F. It's just F. Okay, so the net force on block A, is that just F? No, it's the force of tension. So I'm going to need to figure out what this force of tension is to determine that net force. So I'm going to write a net force equation for A, which will be the mass of A times the acceleration of my system, which will be equal to Ft. So I want to figure out what Ft is. I know mass A, but I don't know the acceleration of the system. Can I calculate the acceleration of the system using a different equation? Yes, I can use my system. So I'm going to use my two masses, the system mass, times the acceleration will give me F. So mass A and mass B, I need to make sure I convert these to kilograms. So move the decimal place over 3 times. So 0.1 and 0.05 kilograms. 1, 2, 3. Oh, wait, yeah, 0.1 and 1, 2, 3. 0.05. So the two masses together, that means, are 0.1 and 0.05. Times the acceleration will give me that force. And I'm solving for A, remember. So this force divided by that sum of the masses, so 0.15, will give me the acceleration of my system. So this is what I'm going to plug in all the way over here. So F net of A, my mass of A is 0.1 times this F divided by 0.15 will give me my force of tension, or my net force on A, which is what I want. So 0.1 divided by 0.15 is 1/3, because 0.1 is 1/3 of 0.15. Or sorry, 2/3, it's 2/3. 0.1 is 2/3 of 0.15. So my answer for what is the net force on block A? 2/3 F. Okay. Now, what is the net force on box B? That's my next question. And I'm going to do it similarly. So I'm going to look at D. So I have my net force on block B is going to be MB times A, F minus FT. Well, good thing I already solved for FT and I already solved for A, because now I just need to plug stuff in. So I've got .05 is my mass times the acceleration, which is still F over 0.15. And that will be equal to F minus 2/3 F. Because remember, these forces of tension are equal and opposite. So that leaves me, and I could solve this 2 different ways actually, and I'll get the same answer. If I solve it using this equation, I'll get 1/3 F as my net force, because 0.05 is 1/3 of 0.15. If I solve it using this equation, I'll get 1/3 F. So either way I solve it, I get the same net force. So how much force does blocks A exert on box B? We know that that is this force, right? It is that force of tension on A by B, and this one is the same. So these two answers are going to be 2/3 F, 2/3 F. We already found that that force of tension was 2/3 F. So another way of thinking about these problems is by these block problems is by using ratios of mass. So the net force on A, so this is the ratios of mass. The F net on A will be basically the mass of A divided by the mass of the system times the net force on your system. And that's because this is the same thing as saying MA times F net on your system divided by the mass of your system. And this, you might recognize, is A of our system, right? F net equals MA. F net divided by M will give us A. So that's why this works. And our net force on box A, mass of A divided by the total mass, that's 2/3, right? 100 grams divided by 150 grams, or 0.1 kilograms divided by 0.15 kilograms. That is 2/3. Force on box B, we have 0.05 or 50 grams divided by 150 of our total system. That is 1/3. And then it's times that total net force on our system. So that's just another way to think through these types of problems, these block problems. So your homework, the rest of your homework, is to try and rank these. Then you're going to do your FBDs and F net equations for these 3 problems. So draw an FBD and write net force equations. All right, I will see you tomorrow.